volunteer as a minute taker, but we are happy to have. Oh, there he is. Great, awesome. And now I know that he's in the room. That was going to be one question. The other one is if you do feel like adding to the minutes, please add them directly to the Etherpad, or feel free to send it to the chairs after the meeting. If you go to the mic, you have to write it in Etherpad. You're yeah. We need a mirror or a lens to split. An optical splitter. You can start the blue sheets, I guess. Well, we're going to get started. My co-chair for this, I'm Lou Berger. My co-chair is Pat Taylor. She stepped out for a minute and should be back any second. She really does exist. When she comes in, maybe we'll get her to stand in the box up there for the video, but I'll just get started from here so I can drive the slides also. Welcome to the Deterministic Networking BOF. This is a follow-on to a non-working group forming BOF a couple of IETFs ago. The slides, agendas are in the usual places. As I mentioned earlier, just be aware that the slides are, the links are broken, and the .pdfs are broken, and just go to .pptx. I think Henrik came in just to hear that remark, so he'll know what to fix. Thanks, Henrik. As always the case, this is an IETF meeting, and we have the IETF note. Well, now Pat is here.
Yes. Sorry about that, guys.
Should I just keep going? Or you
Um,
want to go?
I'll just go. Do I need to say more about the note? Well, other than just sort of. Okay. All right. So we are doing audio and streaming and recording of this, which brings to mind, did you take care of the minutes?
Yeah.
Okay. So please speak only using the mics, and please state your name before speaking. And we need minute takers and Etherpad folks, and I'm told that's taken care of. Please make sure you sign the blue sheets. And we've got the online agenda and slides, and we are working on getting some of the links fixed. Or we hope someone's working on it anyway. So, the objectives of this BOF. This isn't to say we have a solution or to say that the work is done. This is to investigate whether we're ready to start work. So, it's to gauge interest in forming the BOF. Is there a problem that needs to be solved? Is the problem within the scope of IETF, so is it appropriate here? Is there an engineering solution possible? Is this a research project? In that case, we shouldn't do it, but But if we believe that this is a project that's doable in a reasonable amount of time, where we know most of what we need to know to get it done, and can work out the rest amongst our experts here, then we'd like to start it. Do we have sufficient contributors to get the work done in a reasonable time? And the other thing that this meeting is for is to provide input into the ADs and the IESG on this project. So what are we talking about here? What's DETNet? So that stands for Deterministic Networking. Guaranteed delivery, where guaranteed means no loss due to congestion. Obviously, at times there's going to be a bit error. There are some mechanisms to try and deal with even that, but guaranteed delivery of a data packet within a guaranteed window of time over routers. And for some background slides, Norm Finn did some presentations, and there's also some presentations from Michael Johastiner. So there's three origins of the interest in this. One is industrial networks, where the network is being used for control. In place of, currently there's often specialized buses that are used for this, or proprietary forms of Ethernet that are used for it. Transportation networks, where again we're trying to do some real-time control and need to get data through in a prompt fashion. And entertainment, either live performance or recording, where the sound needs to get to the headphones the musician is wearing. And those all combine together into something that IEEE 802.1 TSN, time-sensitive networking, is standardizing for layer 2 networks. But that doesn't cover when the network extends across layer 3, when it's routed. There are individual market needs and vertical standards that are now in use, and local area network standards being developed. And we'd like to get to having some internet standards too. So the idea is to have standards that are independent of the subnet technology. So some upper layer standards that will run basically over a common network, regardless of the underlying technology, physical technology of that network. Okay, so there's some standards work going on in IEEE 802.1, as I mentioned. So one is doing an update of the time synchronization standard that they already did. One is for frame preemption, and there's an accompanying 802.3 project for doing that over Ethernet. So that is in order to allow it to be more efficient, to send this time-sensitive network at the scheduled time that you've reserved for it, or as soon as it comes in, and while leaving as much bandwidth as possible available for the other traffic. That's probably not something that's not. I don't know if that one's one we need to deal with here. And then there's enhancements for scheduled traffic and stream reservation protocol, and the standard for networks, frame replication and elimination. That's related to the getting the guarantee of getting the packets through higher by sending packets along two paths, and then eliminating the duplicates at the receiver or near the receiver, so that even if the packet gets hit by a bit error on one path, you have the other packet to get through. And then cyclic queuing and forwarding. which is basically a pacing standard for getting the traffic out at a metered rate, and per stream filtering and policing. Right now, they're considering combining those last two into one because they're very interrelated. Okay, there are also some IETF technologies that are related to this area. DiffServe, with various control plane and data plane protocols. IntServe, also control and data plane. And traffic engineering and the encapsulations for the and subnet protocols. So layer 2 VPN, pseudowires and MPLS, and IP tunnels, and 6TISH. So the objectives for the working group that are proposed: define operation of deterministic network flows over layer 2 bridged and layer 3 routed segments. Define overall architecture for the data plane, OAM, management, control, and security. Define the DETNET data plane. The expectation is that this would use existing mechanisms, not new encapsulations or new layer 2, layer 3 formats. So it seems like, as you saw on the other slide, that there's a wealth of formats to support this with, and a belief that we can work with the existing formats. Define parameters for control and management of this, and define management models. So the agenda today is the user's view. So to understand what it is that users need out of this, what the use cases are that this would be based on. What's the problem we're trying to solve, and is it solvable? So a DETNET problem statement, including some example possible plausible solutions. That does not mean that those are necessarily the solutions the working group would choose to use. It's more of an existence proof that this is a solvable problem. Working group scope and deliverables discussion. So how are we going to organize the work? What output do we expect to produce? And then the concluding discussion and polling. Do we have people who are willing to do the work? Okay. There are drafts up related to this. Now, that does not mean the fact that there are these drafts, these are all individual drafts. It doesn't mean that we all agree with these drafts. I'm sure that there are things in these drafts that anybody can find that they would disagree with and would want to change during the working group work. But these are kind of some starting points and thoughts, and showing that there are people who have thought about this problem and are ready to start addressing it. Okay. This should be the right one. Nope. Okay. So, who's speaking first? Is it Yoni? Yeah. Oh, it's okay. So Yoni, and this is supposed to let you advance, and you'll be the guinea pig, and we'll find out if this works.
All right. So a couple of things. So this is a set of small presentations. So each of these presentations is going to go through a small use case and why the DETNET is useful for it. It doesn't work, so okay, just tell us when you're ready. Next one. So we are going to go through 5 different use cases. So we have something for the industrial applications using the wireless, professional audio, electrical utilities, then the building automation system, and also a bit about the mobile access networks. Next one. And each of these presentations is supposed to answer this question. So what is the application that we are looking for? How we do in this application domain today, how we actually solve it today? What is the intention, what we want to do differently in the future? And especially what we want IETF to deliver as a solution for this specific application domain.
Can I ask just a quick question, because I tried to find the slides?
Name, please.
Mary Barnes.
We announced a couple of times in the beginning that
Okay,
the PDF links are broken.
Okay.
Just put PPTX
Okay,
instead.
thanks. Okay.
The other thing is on the Etherpad, if you're on the mail list, just click on the Etherpad link and you then click on the PPTX
Okay, thanks.
links.
Okay, that'll be helpful for some of us in the back, because it's really hard to see.
Yeah, I know. These long rooms with small screens are really tough.
All right. So let's get started. So the first one is Pascal.
Hi, next slide, please. Oh, no, it's Professor, it's Gunther. Craig, are you here? Yeah.
Hello, I'm Craig Gunther with Harman International. I'm going to talk a little bit about the professional audio need. So let's go to the next slide. So when you think about professional audio, it's environments like this for small environments. A lot of music and film production. If you watch ESPN Sports Center, anything you've watched since last June, I believe it was, is all based on some of the technology that we're talking about here that we need to expand upon. Broadcast, cinema, live. Live gets a little bit interesting when you try to do lip sync with like a video screen of a projection of someone performing. It's okay if the sound gets there a little bit late. It's not okay if the sound gets there before their lips actually move. That's a little tough for people to even comprehend. Their brains don't like that. Some of the problems you get into, have you ever in your life been on a WebEx call where there's a bit of delay in the audio and someone starts to say something and someone else does, and you stop and you start and you stop? That's the things that just can't work in live audio. I've got a couple of examples here of stringent latency requirements, and I'm going to talk about some of these requirements in a second. But in a live production where you have speakers around, you need to get audio out there synchronized at the same time, or really strange things start to happen with the sound fields as they collide. So those have to be designed, and the latency has to be low enough to provide the design criteria. So here's a little example of a live show that happens to be an outdoor show with some really stringent latency requirements, but there may be a recording device, perhaps a mobile trailer that's going to record the proceedings of the event, or perhaps back to a studio. So the stringent latency requirements, that'll often be in a layer 2 domain, but then getting it out to the recording truck, that's often going to be layer 3, and it might even be wireless, because you don't care when it gets there, you're recording it. You just care that it gets there. So we don't really want to send two streams around, one for the stringent requirements and then a second stream to get out to the trailer or the recording device. We'd rather have one stream around and be able to have that be a layer 3 stream and then peel off the parts we need for the local environment. This little diagram, the little diagram here at the bottom shows an example. I don't know if you're aware, but in Craig's opinion, many of the modern artists that you see today singing can't sing worth beans. You'll find a little device. If you watch as they pan back, you'll see a little device down here next to the microphone. That's a device that might mix the guitar output with the notes that it's playing, and it'll adjust the singer's voice so they sing in key. So watch for that next time you see certain modern singers get up to perform. They just cannot sing on key. So in order to do that, this example shows I've actually got 3 streams flying around the network here in the bottom. I've got some microphones and guitars that are going into some kinds of digital processing. Then a stream comes out of that and goes into some kind of a mixing console like you'll see at the back of the room here. And then a third stream comes out of that and might go to an amplifier or some self-powered speakers. So as you take all this processing time together, another problem a drummer has is he's keeping beat for the band to play. If he receives that sound back in an earbud that's more than 10 to 15 milliseconds delay, he cannot play the drums because he gets all messed up trying to catch up with the sound that's coming late to his ears. So you take these various delays, 1 to 2 milliseconds for digital to analog, analog to digital encoding. In each of these devices, you've already burned up more than half of your budget. So the streaming itself has to be extremely low latency to get that through and get it done in time so that it can be mixed correctly. All right, Pat, if you go to the next. So the world of audio, if you just look at the back of the room when you leave, you'll see we're running 1/4-inch analog cabling. Well, when you have a concert with all kinds of amplifiers and guitars and microphones, you have these things called snakes that run to the mixing consoles, and they're about as big around as your fist. And that's to carry dozens of streams of audio. Right now, with AVB, we can carry hundreds of streams of audio on a single RJ45 cable. So the first obstacle we had was to get people off analog and onto digital. That's been underway for quite a while. If you go to any major theme park, pretty much all that is digital these days. We have done that migration, but the technology that's been used in the past, before AVB, has been extremely expensive. The devices you have to put in each of your talkers and listeners or sources and sinks are incredibly expensive for the equipment suppliers to provide, and so that's been kind of a drawback. We have to over-provision the network currently to make sure that audio gets through. And as a side effect of that, these networks are double wired. You have a data network and an audio network. They're going to the same places, racks of equipment right next to each other. They're all doing the same thing. One route's audio, one route's good old-fashioned data. And part of the large buffering we have to provide to make sure there's enough time for that audio samples to get there results in some large buffering. And what I find really funny is, me as an engineer, I am not allowed by IT to touch the data network. It's screened off chain link fence. I can't get in there and mess with switches. Well, the IT guys are screened off from the audio networks. They can't get in and mess with the switches or whatever because the audio people are scared to death that the data people, the IT people, are going to do something to screw it up and bring a show down. So I find that humorous that they have their own worlds they can't get into. So then we've gone from analog cable to an expensive digital process, and now we've brought AVB, which works really great in a small environment. If you think of a studio like ESPN itself, I believe they have 4 or 5 studios. Each one of those is a little layer 2 island, but they're not interconnected. They do some layer 3 interconnecting, which is very strange at the current time because we've had to do some things to make that work, and we want to get past that. But I provided a link, and unfortunately it didn't work in the PowerPoint set when it finally came out. But one of Harman's competitors, Meyer Sound, has done a really cool thing in a big theater in China where they have thousands of speakers, including speakers in each seat, and they're using AVB in there with lots of nodes. All those nodes are extremely low-powered, and low power, low buffering, all that we need to in order to get the dollar savings. And again, we're just looking for ways to make this more standard and reach further around now. So let's go to the next slide. So right now I was telling you about the ESPN studio. They're running, and I consider this a large amount. You guys that do backbone are probably going to laugh at these numbers. For an enterprise level, this is pretty impressive to me. They're running 46 terabytes of data around their studio network with 60,000 streams across 1,100 miles of fiber. There are some interesting situations where large theme parks that have parks around the world may have an event that happens at one park, and they want to send that over layer 3, and this is over the capital I internet, to the local theme park, and then intermix that with layer 2 content. And once it hits there, it has to be perfectly synchronized. We allow for some buffering as it gets there. So we have some interesting needs to get layer 3 content across our layer 2 networks. Although we do have AVB right now, it's only on these little isolated islands. The other thing the customers want, we've done such a good job of convincing them to go to some standards-based things, they're not ready to move to the next step until it's standards-based. And that's why from my side, from the IEEE and the layer 2 side, we come to IETF to get it done right from the layer 3 side. So again, it's standards-based. Want to get rid of the specialized engineering. We don't want to have all these dedicated engineers who understand switches and all the weird things you need to do. We want it to be easy for the customers to use. Right now, they are scared to death to change any configuration mid-show because it has to be manually changed. We want this stuff to just work. As we change things, we want it to just work. These protocols all work together. And the nice thing about AVB that they've enjoyed so far is, even though we have all these strict requirements and all these reservations and everything, anything that a reservation doesn't use is turned back over for regular old data to use on the network. So we can reserve pretty much the whole network, even though we don't use it all the time, and any unused gets turned back over for regular Ethernet traffic. All right, let's go on to the next slide. So what is it we want from the pro side? We often refer to it as campus or enterprise-wide. And enterprise-wide, in one thing I could tell you about offline, is 27,000 acres of property for a theme park that's about the size of San Francisco. They don't really want to do that layer 2. That tends to get a little tough. So they want layer 3 routing on top of these islands of layer 2. Again, content delivery with the lowest possible latency. Remove the need to over-provision, and the thing they're really excited about that I didn't put up here is, well, I guess I did, it's my next bullet, is combining the networks together. But they're also using IntServe within the local areas, and then DiffServe going across the capital I internet, trying to get as much as they can out of that. So we need both IntServe and DiffServe with hooks down into AVB. As I said, the ability to combine these networks into one network and share data in AV is going to be a tremendous reduction in their infrastructure costs. And by the way, when they can do this, all of a sudden they can do redundancy with their networks that are hooked together. Oh, we just lost something.
I don't know.
Could I ask just a quick question about what the requirements that you were just talking about? Because I just don't have a feel for this at all. Rough drums. What is the kind of time frame for setting up the routing across layer 3 and the frequency, the dynamic nature of it? You know, are we talking about setting up 1,000 flows a second or 1,000 flows, and they're just, you know, they're set up for a long time? What's the kind of?
Okay, in the pro audio world, again, there's a nervousness. This is new stuff.
Yeah.
So what they're doing right now is they're setting it up and they run with it.
Okay.
It's not like we're going to change scenes and tear everything down and set everything up. They're sticking pretty consistently with a base configuration and then some dynamic things that happen on top of it.
Okay. Great. Thanks.
So anyway, that's what we need from the pro audio side, which covers a little bit of video. So thank you.
Okay, good afternoon. I'm Patrick Veterval from Cisco, but...
Hey, get closer to the mic, they can't hear you.
Okay. Patrick Veterval from Cisco, but just for quite some time, just forget that I'm working for Cisco. I'm representing the utilities there on the requirements on the deterministic networking. So next slide, please. Okay, so mainly what a utility wants to do is, the first thing is to increase the reliability and the availability and the optimization also of their distribution lines. Okay, in order to do this, they have to support two main things. The first thing is the reliability. You have to know that now there is more and more distributed source of energy. And it's a factor that decreases the stability of the grid. So they need to put more sensors on more actuators in order to increase the reliability. The second thing, they are also moving to what new IEDs, so it's intelligent electronic devices that support new standards, always for the same thing, for the optimization of the grid. And these new standards, and specifically the 61850 IEC standards, it requires now, I would say, more dramatic requirements in terms of delay, latency, jitter, on all this stuff. Okay, we are talking, for instance, right now about latency of 4 to 8 milliseconds. We are talking about jitter of probably 250 microseconds. We are talking about symmetric latency on the line. So these are the type of requirements that we have for this new equipment. The second requirement that they have is to optimize their telecommunication network that they currently have. Okay, and they do not want to dedicate anymore specific telecommunication network to a single application. So they want to mix both, I would say, the OT and the IT on the same network. Okay. On doing this, in fact, they are currently moving from their typical TDM network to a packet switching network. Next slide, please. Okay, so I'm taking the example of a small utility. Okay, I can say that because my co-author is not in the room. This is the Hydro-Québec one. So you can see that you have probably 514 substations. This is mainly the main transformers that you have on electric distribution line. We are talking about 60 generating stations. That's probably a hydroelectric plant, but it could be nuclear plants or this type of generation. You see that for the region of Quebec, we are talking about 10,000 of kilometers of optical fibers, and we are talking also about microwave. The reason is because optical fiber can break, microwave not, okay? And they experienced this in the past. So mainly they have to interconnect or probably close to 1,000 of telecom site, okay? And telecom site could be a transformer, could be a SCADA control center, or could be a nuclear plant. Next slide, please. Just to give you the size in terms of length of the cable, this is the size of the Quebec country. So mostly the generation, okay, yes. Okay, the generation plant are in the north, and the consumers are in the south. And there's probably more than 1,000 of kilometers between the two. And when they interconnect substations, it's probably around 300 kilometers. So you can see that even at the speed of light, now you have some requirement there. Okay, next slide, please. How do we support the application today? Many, they are using time division multiplexing lines, so SDH or SONATE. They have dedicated network per application, as I was mentioning. When you have teleprotection applications, mainly you deploy your own telecom environment to support one single application, because you do not want to have anything that interfere with your application, okay? How they are doing this? You have intelligent devices at both ends of a line. On a line could be, as I mentioned, 1,000 of kilometers long, and it's a 750 kV lines, so you don't play with this type of voltage. Okay, and what they do today, even with TDM, they are doing a calibration of the end-to-end devices. So they are almost zeroing the delay of the line. And this type of calibration could take probably weeks of effort to do this, okay? They are not mixing at all OT and IT stuff on the same network, for sure, for the reason that I just mentioned. And I was talking about these new requirements coming with the new standard, the 61850 standard. So they are currently just deploying this new standard. And in the time scale of a utility, this type of equipment will be there for 20, 30 years. Okay, so they have some time to deploy it. Okay, so these requirements, they do not have any, I would say, real network to support this new 61850, except to have specific telecommunication network.
Got about 2 more minutes.
Okay, next slide. What do we want to do differently in the future, and what the IETF needs to deliver? So the first thing, you know that they are moving to packet switching, so to IP, and for them it's a big thing. So they want to have the support of deterministic networking using open standard. And if it is an IETF standard, it's better for them, because they are trying now to learn IP, and so they believe in the IETF. What they want to do is IT and OT convergence, just because there is a business case behind this, okay? And that's really what they want. Layer 2, layer 3 topologies, you can see with the, probably a substation is a layer 2 island. And when you connect this to the control center, the SCADA control center, and you have a substation to substation connectivity, it will be probably a layer 3 connectivity. And you saw also that they are mixing microwave connectivity with optical fiber, so we are talking layer 3. The next thing is that the utility really wants to control everything. So if we offer a solution that is centralized computing for the deterministic path, it's really good for them. They can live with distributed, but it will take more time to the IT guy to convince the OT guy that distributed is something that works as well. So centralized for them is their first approach. Thank you.
Keep in mind when you're hearing these user perspectives, this is just their perspective on what the problem is and what they would like to see. This is input to the discussion. It's not reflecting specific chartered items.
Okay. Hello, my name is Subir Das. I'll just walk through quickly that some of the building automation use case, which is simply called BAS, another acronym. Next slide. So, yes.
If you're going to turn around the screen, please hit the mic up because I'm just typing it out here.
Oh, okay.
The mic comes out if you want to just hold it.
Oh, I see. Okay. Hello. How about this?
Yes.
Okay, good.
Stay in the pink box.
Oh, I have to sit it here. Okay. This is the firewall, right? Okay. Yes, so you heard about what is the requirement for the deterministic network, right? Okay, so coming back to this, this is actually the building automation system, including like every building and the enterprise and others. We know that obviously that everything is today managed, and there is an operator. The operator could be the local operator within the building, or operator could be outside, which is remotely operating that or managing the network. So in a specific deployment today, there are two types of network in the building automation. One is the field network within the building itself, and is the management network. So the management network and the field network can be co-located within the building itself, or it could be separated. But the interesting part, what is happening here, that there is in between, there are some local controller. And as you can see that lower tier, there is lots of devices which are sensors, like it could be room lights, doors, HVAC fans, and whatever it may be. And then there is local controller which has a different field device requirement, which we know that in the right side here is that the requirement of that communication cycle is 50 milliseconds to 200 milliseconds. That's the typical range. On the other hand, in the communications of the management, local control to the management actually can vary from seconds to minutes, and it actually configured. But the interesting point is that in both the cases, the availability is a very high availability requirement for managing this kind of system, both from the field network system and the management system. And you see some of the acronym, what we use, the building management server, human interface machines, and the local controller. Depending upon the different kinds of specification on the standard, this terminology may vary, but in essence, that all these things are using the three kind of devices. Okay, next. So what is today's state of art is that lots of management network. The management network are mostly in the building at the back net, those folks who are familiar with that standard, and it also supports IP, it runs over IP. And then, sorry, there is a typo actually, it should be HIM, not HIS. These are mostly on the servers which are connected to the network. So the management network, as we have noticed in the previous slide, the requirements is actually seconds to minutes. But in the field network, most of the today's network are non-IP based, which has, there are lots of different standards, and some of the example in the Modbus, Lone Talk, and some of the proprietary protocols. And there are also the local controller, depending upon the different kind of standard specification. What we need is different kinds of adapter on the connector, right? For the example, RG45, RS485. So what it means that in a typical scenario on the typical building automation system, there could be all these three different kind of proprietary standard protocols as well as proprietary protocols. It ends up different types of connectivity, and then local controller needs to be connected with the multiple wires, and it gets more and more complicated as you add that, and there is no such interoperability between the different kinds of protocol. Next one.
Okay, 2-minute warning.
Okay. So what is results to? That's how do you want to do it differently in the future. So what we have seen that architecture and the model which it works today and perfectly it works, but on the contrary, what happens is that it increases a lot of different complexity. For example, different MAX5 specification, and then it does not interpret, and then in the vendor lock-in, that means that it's not very cost effective. Even for the provider who provide that, building automation system, they had to interwork with multiple different standards, and that's what it's an expensive bass ended up. And also that other important point is that these systems were developed for quite some time back, and there is not inbuilt security. And I added one example here. I think that, folks who are United States, that almost 2 years back in Thanksgiving time, there was a Target data breach. And if you know that, and possibly some of you know, that attack was not happened through an IT network. The attack was actually happened through an HVAC system. So there was no security in that, and then through the HVAC system that, it's an insider attack happened. So the important lesson is there that every part in the network is equally important and needs to be secured. For example, that lot of the example, the standard device, there is no authentication. So I can, if I enter to the building, I can attach a device, and then I can connect and become an insider. So the next slide. So what we would like to see that from this community, I think it would be helpful that if we have an kind of IETF can deliver both in a protocol specification and the architecture for which that, the delay, communication delay could be less than 50 milliseconds, and also the network availability is almost, the 100%, because mostly from the local controller and the field network, because that's where that all the, action happens. And then, of course, that's some of the QoS requirement. So that would be helpful for, and then the complexity and the cost of, building automation system will be greatly reduced.
Thanks, Subir. So it works finally? I can turn this thing? Yes. So I'm Pascal Tuber with Cisco. I was also an editor of IETF93-DETNET-20150720-1300, which is a standard for industrial wireless deterministic sensor networks. And I'm also co-chair of 6-Dish Working Group. So I'm here to represent the industrial world. 6-Dish actually takes its roots in industrial networks. And those networks have been deployed for like 40+ years doing deterministic traffic and very high delivery ratios. And they have entered the wireless world in the last 10 years with wireless heart and IETF100. And there are a number of reasons why they went wireless. One of them is that cables can break. So wireless is actually an interesting solution for diversity. Another one is that, well, wires are not always feasible. For instance, if you have rotating devices or moving arms, etc., the cable becomes an hassle, and then there are reasons of cost. So what are we talking about here? We are basically talking about replacing or improving 40 years of technology with deterministic IP networks. And why would we be doing this? Well, it's always a matter of cost, reducing cost, and augmenting the value of the network. To reduce cost, people in the industry are already starting to evolve from dedicated field buses to Ethernet and IP technologies. But those are still siloed, dedicated technologies, and you cannot connect multiple standards over the same Ethernet networks, even though on the line it's already Ethernet. So there is still a high operational cost in operating multiple different networks with different people which have to be formed for those networks and manage them and operate them. The second and probably most critical reason why we would like to converge this IT network and this OT network together is to bring in the operational network some of the value that actually is only available on the IT side. And a critical aspect of that is the capability to monitor large-scale amount of devices over the same fabric. And so basically, that's when we started introducing IP routing over these deterministic type of networks. So in summary, added value because now we can use the same fabric to monitor tons of stuff and improve the operation of the network, this 1% that GE is claiming will save billions of dollars in the industry, and share the same infrastructure for deterministic and IP traffic. How does it work today? Well, basically, you'll hear here the same story as you've been hearing in the previous cases. We have industrial networks which operate various protocols as silos. Each silo is defined from the file layer to the app layer separately. And when you deploy them, you have to deploy multiple of them, and that multiplies your operational cost. What we are after is bringing in the hourglass model into that world so that you have multiple applications and you can deploy new application over a same network. In the case of wireless, that would be a 6-digit network. So what do we see differently in the future? So first thing, I just mentioned that the hourglass model, the end-to-end principle to replace all the silos. That's critical if you really want to save on the OpEx side. We want open protocol, open source implementations so that we can actually compare the value and apply to different environments. So not only industrial, but at some point you can export that down to the management of the rest of the campus. Critical, we want to be able to mix IP traffic with the industrial flows. Right? That's really what's behind this concept of convergence of operational technology and IT technology. We want to use the same fabric, same network management, same people to transport not only the operational flows, but the IP flows as well, and be able to monitor all those devices. As we are doing this, we still want to guarantee to the operational people that the flows that serve their needs will have the exact same behavior as if there was no IT traffic, which means that we need to reach a new degree of isolation between the flows on the same fabric. So when you have a deterministic flow going over this converged IT-OT network, you want to make sure that the operational flow has no clue whatsoever that there is an additional traffic on the same network. There is no influence whatsoever on the deterministic flow by other flows on the same network. And finally, we want to be able to run those flows across the factory, which means beyond a given layer 2 domain. And interestingly, since we see that wireless is an interesting diversity to wire, we might be able to send a flow on the wire side and on the wireless side in parallel. And these are evidently two different subnets. So when we asked what we would like the IETF to deliver, what I brought in here is a picture of an ISA 100.11a network. This is from the ISA 100 architecture, and this is what ISA delivers. And what you see in scope of the ISA network is really how you build one mesh. And they have figured that because they have tens of thousands of sensors in one network, they need a backbone to federate that all. But the standard does not define the backbone operation. They have figured, it's written in the standard, that this is a router. And this is probably Ethernet, though it could be a different field bus. But this piece is not standardized. They don't know how to actually aggregate all those small meshes into one larger subnet. So what do we want to deliver? First thing is we want to go from a silo network, an ISN network in this case, or wireless HART network, into a single converged network. Second thing we want to achieve is the way to define a flow across this network, whether you're on the mesh here, and that's defined by ISA, or if you go across the plant network, which is not defined by ISA. We want to provide replication and elimination end-to-end. ISA will only define a little replication over one hop between one node and two APs. So they have the concept, they have the need of replication, but they have a very narrow and limited capability for doing this. And then, as I said, critical, we want to be able to share this wireless infrastructure between the critical flows which they operate today and IP traffic in general used for monitoring, viability, estimation of the devices, statistics, all sorts of information which will be brought back to learning machines, which will enable improving the operation of that network and gaining those few percent that they're after. And ultimately, we want to be able to have a flow which goes from a sensor across this backbone down to an actuator, which is somewhere else. And eventually, we want to be able to run some virtualized operational technology, which is today a physical device on the same network, which would actually reside somewhere down in the plant network. So this really means we want to be able to establish end-to-end deterministic and that be part of the standards, which is not the case today. And that's it for me.
All right, so the next one is looking into the radio access network in a mobile space. So the application is basically the connectivity. So there's a actual multiple domains in here. So one is the connectivity between the radio heads and the base station and the for the remote radio heads and the baseband processing. One network connectivity is between the base station, so when base station need to coordinate, for example, between each other or share the connectivity between each other. And also the whole backhaul thing from the mobile core network towards the whole radio access network. So most of this stuff is like a business as usual. We have been doing this for a long time, so we know how it works. But for the forthcoming next generation of the mobile networks, the timing constraints are going even tighter than they are today. So we are talking like 10 times more tighter timing requirements. So we are seeing that we're talking about below 10 millisecond round trip times, even certain applications going down to the 1 millisecond round trip times in the from the mobile device to the edge of the core network. So how to support the applications today? So from the front haul connectivity between the baseband processing and the radio heads, that's mostly dedicated point-to-point connections today. Proprietary protocols and framings and so on. So there's actually very interesting work starting now, ongoing IEEE to bring Ethernet in this environment. So just got started like a couple of weeks ago, last week. Something to keep eye on. Mid-haul, backhaul part is mostly IP networks, Ethernet, MPLS, TP, and so on. We know how to do this, but the thing is that our latency, jitter, and timing requirements are going even tighter than they are today. So what I would like to do in the future differently. So looking into the data plane solutions where I could actually make use of and leverage the underlying deterministic link layer services. For example, the Ethernet-based services that the time-sensitive networking is producing, how to make use of that. And also build on the, also make use of the, assuming that I have the kind of end-to-end unified data plane, leverage the existing network management systems to run the whole end-to-end network. So in the context of DETNET, what I would like to IETF to deliver. One part is the working on the data plane transport specification. Look into if there's something that we could unify for all these parts of the network. And the other part is the building the standard information model that would understand the environment in the specific access network environment, and also be able to utilize the deterministic networking services that I have on the link layer on the below the layer 3. Right. So going forward, So as we heard about this, all these the different applications that are looking for the networking, couple of summarizing common themes that came out of all of these. So time sensitiveness is one thing. So guaranteed delivery, delayed variation guarantee, and the as small latency as possible. Also, there was multiple presentations asked for the kind of common unified standard, single solution, no more silos. So especially in the certain industrial and that kind of environments, a lot of different solutions, bring one common data plane and provide vendor interoperability in that way. Also, one thing that came out is the desire of running different type of traffic in the same infrastructure. So be that layer 2, layer 3, or running layer 3 over layer 2 over layer 3, but you must be able to mix this different type of traffic and be able to pin those paths that have different characteristics. Right.
Okay, so this last slide is summarizing the user views that we went through. We're going to have time for more discussion later, but if anyone has a clarifying question on any of these sort of use cases, you're welcome to ask now. I'm sorry, we're having trouble hearing you.
John Doe from Space. So, deterministic Ethernet networks have been around in AVMs for some years, like about 10 years, including around Airbus 380 or remote, so the next underneath will see deterministic Ethernet. Those applications, there are passive supplying to them. So, it's a warning, but just a note really that whenever you end up coming up with, it's obviously got to avoid whatever intellectual property is established on under those use cases.
Yeah, as always, we have a process for disclosure of IPR, and we certainly would expect any participants in the working group to, in an eventual working group, to follow the rules of the IETF and disclose those.
I picked up a bit of internal confusion listening to Norm. I understood...
Norm hasn't spoken yet.
Sorry.
One of the other speakers, okay.
It was the audiovisual presentation. What I heard was a connection of deterministic layer 2 islands over an IP internet. I also heard a mention of running IP over deterministic layer 2. And I wondered whether this is both in scope, both needed together, or some accidental different terminology.
No, I think from my view, I think you picked up on something just right. I think you have some users who are interested in just connecting islands, and some users who are interested in doing the normal router IP thing. And I think it's part of the discussion, what we do, if both are in scope, what order do we do things. But I think that's sort of almost ahead of ourselves to talk about that right now. But I think you picked on something just right.
Right, I wasn't attempting to scope, I was attempting to try to understand what the use cases were.
I think you have different users asking for different things. I think you're just right.
Yeah. So the slide here says a mix in the same network. So they've got layer 2 networks with layer 3 running on top of them, but there are also layer 2 over layer 3s.
being introduced. Is the scope of the working group to define solutions that will actually be used in networks where all these type of use cases will be used at the same time and cross-domain?
I think you just asked a scope question. Right now, we're just trying to clarify what the users are asking for. So please bring that question up when we get to scope. Any other use case clarifying questions? Then we're going to move on to Norm's presentation. The clicker? Maybe Yoni, did you walk away with the clicker?
I'm the Norm he was just referring to. Norm Finn, Cisco. I've been IEEE 802 now for just very short of 20 years, and right now my mission is making DETNET something that everyone can use. So I took my shot at putting together what the users' requirements have in common. One thing I want to stress that didn't come out necessarily in those presentations, the critical data streams themselves. They are all characterized by fixed bandwidth. Every one of these streams, these people are coming from a history of 40 years ago, this was all analog signals, one signal per wire, one signal per cable. 20 years ago, this was digital, but still typically one signal per cable, one signal per wire. RS-232 comes to mind. They're now getting onto Ethernet, but back pressure is not an option. Secondly, it's quite a wide range of data rates, anywhere from 1 per second to 10 gigabits per second. It tends to aggregate together, though, even the slow stuff to be stuff. And in particular, there are systems out there right now that work very well by just over-provisioning and prioritizing the important stuff. That works so far, and then it stops working. You're all familiar, your IP phone works great until it doesn't, right? That goes so far, and we've had many times they want to replace all these scattered ad hoc proprietary solutions with an open standard. Now, what do they want from the network? Something that hasn't come out a lot in here is time synchronization. Most all of these applications require that the end systems and often the routers, bridges in the middle have to be synchronized to better than a microsecond for any of this stuff to work at all. That's a critical part of the overall architecture. We'll go into a little bit more as to how much we need to worry about. The big deal is guaranteed worst case latency, preferably low. We talk a lot about we need low latency. It's not just lowest possible. We've all been in the business of years providing the lowest possible average latency. That's of zero interest whatsoever. What's of interest is the worst case latency that you 100% guarantee. Because in my application, I'm running a 10 millisecond loop or a 4 millisecond loop. I've budgeted this much time to convert the measurements into digital. I've budgeted this much time to transmit it to the brain. I've budgeted this much time for the brain to think about it. I've budgeted this much time for the brain to get the answer back to the actuators. And I've budgeted this much time to start that motor moving. And that's how much time there is. If it takes longer than that, the robot falls over.
Norm, could you move the mic a little bit away? Thank you.
These people know what I'm like without the mic, yeah. So, low, sometimes extremely low packet loss probability. I've talked to people on manufacturing floors that throw around numbers like, if packets were dropped at random, which they are not, but if they were dropped at random, I need a packet loss rate of somewhere around 10 to the minus 12. This is not trivial to achieve this. We also need to convert, everyone has talked about, they want the critical data streams and the existing kinds of QoS, the stuff that we're doing in our networks every day, like VoIP. We all want that to work over one network. What kinds of networks? Bridged, routed, and mixed. This is related. The object here, there exist a number of proprietary solutions. There exist a number of semi-standard solutions that provide a way that if you write your application over this substrate, you can write a real-time application. That's not what these people are interested in. We want to be able to apply this super-duper QoS to networking, period. So yes, islands of L2 separated by L3. Yes, L3 talkers and listeners who don't know or care whether they're connected via bridges and routers. Yes, we want to do it whether there's an SP and stuff. So bridged, routed, and mixed, wired, wireless, and mixed. So how much of that, which of these problems are candidates for DETNET to solve? Time synchronization. I took a chance, I just crossed it out. I think we've got a lot of people working on time synchronization and a lot of SDOs here and elsewhere. I think DETNET can take it as a given that we can synchronize all of our devices to better than a microsecond. Now, guaranteed worst case latency, low, sometimes extremely low packet loss, convergence of this stuff. Yeah, that's the meat. That's what we have to, I think that's what we need to deal with in DETNET. That's where this comes in. Now, bridged, routed, and mixed. 802 has been doing pretty good so far with the bridged networks. If the mixed case is to work, then the IETF routed answers and the IEEE bridge solutions must be coordinated. It's simple as that. How many people in this room were in at the Waikoloa last week at the 802 meeting? Okay, so we've got some commitment here from people who want to see these things work together. And if you don't think getting from Waikoloa on Friday to Prague on Monday is a commitment, take it from me, that is a commitment. So, wired, wireless, and mixed. Now, in my opinion, each wireless medium is different, and they're all very different from wired media. I don't see anybody from a wireless group standing up in there saying, oh, yo, 10 to the minus 12 packet loss, no sweat. Okay? So I think a DETNET working group would concentrate on wired solutions but be open to cooperation with the wireless groups. Okay? Unless there is a wireless group that says, sure, 10 to the minus 12 packet loss is no problem. So now, trying to take a shot at mapping, give me a 5-minute and 2-minute, by the way. Mapping users wants to existing technologies. Now, to recap, the users want a guaranteed worst latency, very low packet loss for fixed bandwidth streams, and converge that with existing QoS mechanisms. We could start from zero and try to invent something all brand new. What happened? What did I do? Okay, sorry, there's another button here. I think it's quicker and easier to use existing technologies, in particular, advanced reservation of dedicated per hop resources. Step one to make this work is, I think it's pretty clear to anyone who looks at this. Step one is to totally eliminate congestion loss. Okay? Why do packets get lost? Number one, congestion. So you absolutely have to eliminate completely any chance of congestion loss. And the way you do that is you reserve resources every hop along the way. Okay? That's well known. And why? Well, we know that can give you you can compute a maximum buffer allocation per stream or class per hop. And as soon as you know the maximum number of buffers you can take for this stream or for this class at each hop, then you can allocate that many buffers and you're guaranteed zero congestion loss. And since you've got to drain those buffers at some point, you also know the worst case per hop latency and that plus the wire length, and you've got exactly what you're looking for here. Okay? So step one, zero congestion loss. And is that enough? Well, for many users, zero congestion loss has proven to be what they needed. Okay? We've been doing that in AVB for a while. A lot of users find that is enough. For example, people build networks around rings that can fail over quickly, and they find that if, right now they're often doing this kind of stuff with over-provisioned rings with priority, okay? put in the zero congestion loss, let the ring fail over with that fast mechanism that rings are good at, and that's good enough for an awful lot of users. And so that's cool. On the other hand, and if you have the zero congestion loss with the provision resources, that allows you to carry a much higher percentage of the network traffic be the critical traffic. We're getting 70-75% in our .1 networks critical traffic, with 20-25%, 30% for the best effort stuff. And that's pretty darn good. And that's enough for a lot of people. But for some, that's not enough. If you need your network to be more complex than a ring, for example, it gets harder and harder as you talk about a mesh network. It gets harder and harder, it gets more and more complex to make a network that can recover from failures quickly. Some of these applications, it's unlikely that you're going to get anything that recovers quickly enough. Okay? You start to run into problems of links don't fail. It's wonderful to live in a world where links fail instantly and silently, where nodes fail instantly and silently. But when you get down into numbers like these, nodes don't fail instantly and silently. They go flaky, they get dirty, people put in crummy access lists, boneheads put in bad access lists. Things get really complex, okay? And you can't depend on the network to do that. So, what people have done, and there are standards for this, we're working on one in 802. This is way more complexity than we need, but the basic idea is that at one point, you sequence number the data stream. This happens to be a dual home talker. You sequence number the data stream. You send out multiple copies of the packet on different paths. There's a red path here that goes a lot of places, a blue path that goes so far. The streams cross. You have points at which you eliminate the duplicates. You say, on this stream, I've seen packet 5. Here's another copy of packet 5. I'm going to eliminate it, pass along just one copy of packet 5. Meanwhile, this other guy's doing the same thing. You have multiple copies. Eventually, every listener gets at least 2 streams coming at it, from which it can eliminate the duplicates, and you have this happening several times in the network, so in fact, there can be several failures in the network, and you still have multiple packet streams arriving at the destination. Okay? Clearly, this goes along with detection. You don't want to live in a fool's paradise. I'm getting my data regularly, even though one stream died 30 minutes ago. You don't want to live in a situation like that. But you can put together systems like this that are quite capable of delivering on the order of 10 to minus 12 packet loss, as long as every single path along here is also eliminating congestion loss. So, the idea is that the paths are typically fixed, and so they're unaffected by network topology changes. The best effort traffic may ebb and flow as the topology changes and the routing or the bridging protocols kick in, but these flows are fixed to the topology. Each flow either works or it doesn't. If it stops working, you flag the network manager to do something about it. The listeners basically never miss a packet. That gets into a little more detail than we want to go. So now the problems for DetNet to solve, and this is my last slide. Number one, we need to configure these DetNet streams. Now that can be by static configuration. That can be by using a central network controller, and that includes both bridges and routers in the purview of that controller. I should stress something here, and I'll mention this. It's been a long time since my company built a box that you could look at it and say, oh, that's a bridge. Ah, that's a router. Okay? Every box does everything. And in a data center, one box is an incredible mishmash of every single user has a completely different architecture of bridging and routing. Okay? And so this box, the logical path of this packet from bridge to router to bridge to end station has absolutely nothing to do with its physical path going up to this box and right back out to a user. In this world, when I'm computing latencies, when I'm dealing with time synchronization, there are no such thing as bridges and routers. There are only boxes and wires. So that introduces some interesting things when we talk about the network controller. What does it control? Anyway, we may need to control this from talker or listener initiated requests and responses. We want to be able to take advantage of the various data plane shapers. You can't do any of this at a high level and expect it to work. There has to be data plane mechanisms. The only way that you can guarantee that you'll never have to have too many buffers is if I don't deliver the data too fast. As soon as I say, well, it would be convenient for me, I have the bandwidth, I might as well deliver a little bit extra data here because I've got the room, that's the next guy's obligation to buffer it. Doesn't work. There are various shapers. We have to be able to take advantage of them. And we have to be able to do it by all these means in a realistic network. There's going to be stuff that's established, imagine in an automobile, okay? The automatic brakes are going to be established with static configuration before you ever start, okay? Then you're going to hang a bumper camera on it, and it's going to maybe be talker initiated kind of thing going through. You can imagine these scenarios. There are going to be applications and users that insist on using a central controller, and everything is done through a central controller. There are going to be ones who insist on using peer-to-peer protocols. Everything has to go through a peer-to-peer protocol. We'll have to work that out. The second thing, after we can control this stuff, and all this boils down to parameterizing the data plane shapers at every hop to do their job, is to select a data encapsulation. And this has to be an encapsulation that can traverse both bridges and routers. It has to make it easy for the bridge or the router to identify a particular stream so it knows what resources to allocate that stream, which of the resources that have been dedicated to allocate to that stream. We have to be able to sequence the packets for the seamless redundancy to work. That has to be visible to the intermediate hops. And in order to get any kind of scalability, when you talk about dedicating resources per hop, per stream, clearly the only hope you have of scaling this up is to aggregate streams into bundles of streams. Now, there are some really obvious candidates of things that can go through bridges and routers, make it easy to identify the stream. They sequence the packets and they aggregate things, okay? It has web feet, it quacks, it ducks for bugs. You know, it sounds like an MPLS bug, duck, sorry. If there's a better way to do it, love to hear about it. That's one obvious way to do that. I'm done.
You can have questions on this presentation. Again, please keep scope discussions until after the scope discussion. Scope questions.
Although I think this is
Can you speak really into the mic because I'm having a lot of trouble hearing?
Yeah.
It sounds to me, once you organize a study, I would suggest to people that they collaborate with one of the groups they call IC study group, research group. So from your presentation, it seems to me there's two different type of functionalities. One is your information delivery, marking point, aggregation, this kind of things. Another one is like you said, kind of like IPS Lite. with the dedicated bandwidth underneath, with the protected switch in whatever we call it, really, the kind can be done in the eyes. So it seems to me to combine the two level different technology together, not be achieved what they want. So this is my comment.
Yeah. Well, I certainly hope it's that simple. Then it won't take long.
Yeah, we definitely think there's a lot of good technology that's been defined that we're going to reuse.
And also one more comment on that, people talk about the mixture of the layer 2, layer 3. It seems to me that has been done for MPS already. So don't worry about that, we will leave that to MPS.
Yeah, I think asking why is this just not already done in other works is a fair, other working groups is a fair question, and hopefully when we go through the scope discussion, it's clear what's different or what's additional.
David, quick question on why a single encapsulation? I'm going to start there. I can answer longer version if that's a lot.
Norm, can we, rather than answer it here in your problem statement, let's answer that in the scope discussion.
Okay.
Fine.
The suggestion is that in the scope discussion, think about two alternatives to the problem. One is single encapsulation. The other is need some kind of protocol that carries strings over lines. The rest is scope discussion. Thank you.
Pascal Hubert. So I'll just figure out what I think I understood from there and ask your reaction about my understanding. One thing you apparently said is that there are a number of tools actually which can be taken separately like a toolbox, and some given application may want to use tool A, tool B, tool C, but may not need another one. I'm thinking about some AVB solutions may not need time sync, or some point-to-point links may not, or multi-point but serial links may not need path replication and elimination. It looks like a number of additional tools that you may or may not apply to a given use case. The other thing that you said is at some point you gave some numbers like 10⁻12, which, as you mentioned, wireless cannot meet, but what I see is a good number of the tools that you have presented can be very useful in a wireless environment to make it more reliable. The problem not being not generally 10⁻12, but user requirements in a particular environment. If you can meet those requirements applying those techniques to wireless, then it's perfectly viable to say I'm doing a deterministic wireless network.
Sure.
Okay. Thanks, Norm. Okay, so we're going to move on. It's to the last slide deck, which actually is covering a couple of things. The first was the discussions we just had. The next is going into what work we have proposed. So there is a draft charter that was put together as part of preparing for the BOF. I'm paraphrasing here, or we're paraphrasing here, not going verbatim from the charter, but fundamentally, there's 4 different areas to talk about. And we're going to go into each one of these individually and talk about the problem, the deliverables, what's in scope and what's out of scope. One thing I realized as going through this breakdown as well as the discussion is that it's not always clear the separation between distributed control and distributed control and a centralized or logically centralized control of where it fits into these last two when you talk about control plane or management plane. And maybe we should just call that control rather than control plane, because we're not trying to predicate a distributed solution versus a centralized solution. We think the answer is yes, those are in scope. So I just want to make that point on this slide. In terms of the data plane, fundamentally we're trying to figure out what does a DETnet flow look like on the wire. And this is something, we did ask ourselves the same question that one of the someone from the floor asked, which is, why isn't this just what's been done before, what already exists in existing working group? And one of the big questions is, all right, who owns the data plane here? Who's going to tell us who does the DETNet data plane? And the answer is there's no one to do it. So that is really where this group starts, is figuring out when you have these flows that are coming across certainly 802.1 TSN, but possibly other technologies, possibly just connecting islands of TSN, but also this other use case that Adrian talked about or mentioned, we need to figure out what it looks like on the wire, what happens in hardware. And that's really where we start. And part of it is an architecture. The other part of it is some standards track specifications. The hope there is that we reuse, and I should go farther. It's not the hope, the intent is to reuse existing standards both at the subnet layer and the existing encapsulation and layer 3 forwarding mechanisms. So what do I mean by encapsulations? For me, I think pseudowires is a primary example of that. Of course, it's for the working group to figure out what the real answer is, but I think that's an example of a technology that we expect to leverage. OAM here is listed as sort of the broad umbrella of OAM, including things like time synchronization. So the group can figure out what's the best way to handle different OAM requirements that exist in the from the use case as well as from the technologies, the subnet technologies we're supporting, and whether we do interoperability functions, whether we carry things, whether we say it's done. Those are things we'll figure out. I include OAM as a broader definition of OAM. Out of scope things, certainly touching someone else's specification. So changing how the IEEE specs work, we're simply not going to do that here. Having a liaison asking a clarifying question, well, sure, we can do that. Having a liaison saying, have you ever thought about doing these other things? Or just informing, making sure that we have good information flow between the SDOs of what's happening. Those are things we're going to do. Changing formats, not going to happen. Changing what other groups do in the IETF in terms of forwarding, that also isn't going to happen inside. That's out of scope for this proposed working group. The working group can certainly say, talk to those other working groups and try to work with them to make changes if we think that's necessary, but we don't see any changes occurring in this working group. At most, there's maybe a code point allocation, but no fundamental changing in forwarding behaviors. And we include modification of encapsulation formats in that. And you'll notice, to David, this is an S. It's open for the working group to decide what exactly the formats are, or if it's a single format. That's part of the work that needs to be done. So, next. In order to do, yeah, please go ahead.
Eric, not Mike. A clarifying question on the previous slide. So there's been discussions about splitting, recombining, and is that something that you would consider being part of the data plane? Because it wasn't explicitly listed on the previous slide.
Yeah. Right? To me, that's a protection mechanism.
Okay.
And there are you have the coordination of there's the setup of the protection mechanism. That would happen, and you can argue whether it's the control or management plane. And then there's the actual protection switch, and at the speeds we're talking about, it has to be in hardware. So I view that as part of the OAM support in the data plane.
It's part of the OAM thing. Okay.
Yeah.
Okay.
So I sort of think about, I have a lot of experience on the MPLS side and TP side, and we've been through all that, and so I sort of binned it into that bucket. Once we have figured out what the data plane looks like, we have to define what the parameters are and sort of what the value space is for describing the DETNet flows so that we know how to control them and how to describe them and allocate resources against them. And that needs to be formally described. We think that's going to be an informational document and maybe part of the architecture document. It'll be its own standalone document. That's, again, for the working group to figure out the best way to run that process. But but we think that's necessary. I think it's pretty clear what's in scope for that. Again, out of scope, we're not going to change mechanisms here. If we're just using someone else's mechanism and describing how to use that, great. If we're defining some new parameters that are important to be used in future control, this is just the information that needs to be used at this point. On the control plane, from an architecture standpoint, we want to describe what we think is in scope and what is out of scope for control of DetNet flows. We do want to identify what existing mechanisms we can reuse as part of that architecture effort. Our expectation at this stage is that both use cases that we heard of centralized or logically centralized control, as well as distributed control or possibly even hybrids, those are things that we think are within the scope of the architecture. When it gets time to working with other groups to define specific solutions, there's certainly going to be an ordering there. But from an architecture standpoint, we think that those are both reasonable things to include in the architecture. But again, this is for the working group to decide the specifics. But any definition of control plane protocol extensions, we would expect to be done within the working groups that own those control plane protocols. Down the road, if we get to a point and someone says, we don't want to do it, we want you to do it, well, that's a discussion we can have at that point with the ADs. It's our intent that it not happen in a future DetNet group, but that DetNet group be gone or just worry about data plane at that point, and that it happen in the respective protocol owning group. On the management plane, we do want to take the information that we identify as part of that characterization effort and make sure that there are adequate Yang models to describe DetNet flows. Clearly, that has to be done in coordination with other working groups and other models. If for some reason we find out that there's another model in development that covers everything that we're looking at, great, we'll just reference that. But we do think it's important as a charter deliverable to make sure that there is a model that exists, whether we do it or whether a different group in the IETF does it. So that was sort of a paraphrased description of our specific proposed deliverables. This comes out of what was approved by the IESG. I think it lines up with what I just talked about, an overall architecture, a data plane specification, a flow information model, and then some expected Yang augmentations. We also may or may not have documents that capture problem statements and use cases. That'll be sort of up to the working group to decide how they want to best capture those. We don't want those to be gating formal deliverables that stop all work until we have those things. In the past, we didn't gate based on use cases or even architectures. We don't want to gate now. Well, that's all we had in terms of describing what it is that the proposed working group is going to do, or what's in charter, what's out of scope, in scope. Questions? Discussion?
Next forward, the question that I put previously applied now. So the question was related to the requirements that are coming from use cases belonging to different entities, and the solutions that will be provided. Notice for aspects and there. Will imply that the solution could be applied on supporting this use case with density. So you have the network to be able to, or so the solutions to the systems that will be used to be able to support all these types of vertical indices simultaneously. That's one. The other one, will this be cross-domain? So will there be different type of operators that are managing the networks, or will it be only one single? And the requirements will be then end-to-end type of requirements, or it will be single main.
Okay, so I think you asked a bunch of different questions. I'm not sure I'm going to hit all of them. What I missed, come ask again. So the first thing is which of the different use cases we're going to support. And so I think they break down from a data perspective of whether we're doing first is the interconnected islands versus the connection of IP-based hosts to each other over different subnet technologies. I think those are both things that are on the table, and we either, no matter what, we should prioritize those, and then we have to decide whether both of those cases are in our scope or not in the scope. And the users are saying they'd like those both to be in the scope. I think the folks who are interested in building or already building product on this also would be happy to do both of those because it's a broader market. It's for this group, and it's for now to discuss whether or not we should include both of those. For one case, I think what we're talking about is basically L2 VPN technology with some extra control on it to make sure everything binds together. That doesn't sound like such a big deal to me. So I see that one as really easy. The other one I think has a little more work. Is it going to be easy or hard? Well, we got to think about it. We got to go do the work. Comments on this point or others?
Yeah, so Eric Nordmark, I think the one thing we haven't talked about is sort of the sequencing of things, right? And it might be that as a working group starting to think about what can you do quickly and show that you can deliver something useful, it might make sense to start with simpler things. So connecting islands might be one of those, right? And then saying, okay, if we know how to do that, can we then go from saying, can I do an arbitrary L2, L3 combined topology, right? And figure out how that would work. There might be another use case, at least the way I see the 6-dish one, and I don't know if Pascal agrees, but it seems like an L3 only solution to me, right? All the devices are IP routers in the 6-dish picture. They might forward things at different behavior, but at least they have sort of L3 configured, right? So that might be another use case where everything is L3.
Yeah, I would hope the L3 case falls out of the second one, but maybe not.
Yeah.
Ralph Drums. Really, excuse me. This is sort of related to what Eric was asking, suggesting about sequencing things. Do you have any sense of the amount of work and the timing and sort of what things can go on in parallel and what just any kind of a sort of projected timeline for some or all of the deliverables?
So we did not go through and come up with a milestone chart with a specific timeline. What we did say is, do we think that we can do all of this in 18 to 24 months? And that we were waiting for the question of what's a reasonable time, because we said reasonable time up there. Yep. And different people have different definitions. So we don't want to give a hard definition of that. But when we talked about it internally, that was 18 to 24 months. And we think that what's here, all of it, can be done in that timeline.
Okay. Okay, thanks.
I'd love to, if one of the ADs or other IESG people want to comment on reasonable timeline or on scope, that's fine.
That feels optimistic to me, but it's your estimate, not mine.
Are we going into Murphy's Law of software estimation now?
Oh, no, we're in Murphy's Law of milestones. No matter which milestone you put down,
we might miss, but I don't think we're going to be, orders of magnitude off. I don't think we're in a IRTF situation where we don't have a firm target to aim towards.
Okay.
I'm not sure I can give a better answer to that.
Order of magnitude scope is sort of what I was thinking about.
Okay.
I think the fact that we have candidate technologies for all the pieces has got to be a good thing in terms of how long it's going to take to finish this. Those may not turn out to be exactly what we use, but we've got pretty good plausibility arguments for all of them, and I don't think we have to reinvent the wheel, at least.
Right. I guess as far as the question that was asked about, are we talking, one administration or moving between different domains of administration? I don't think we know the answer to that. I'm pretty sure that what was said about feasibility of doing this when you're under one administration is pretty clear, and obviously if you're going across multiple domains, then that becomes more complex to make sure that happens. And I'm not sure that is going to fit in the 24 months, but I think certainly for the one domain kind of thing, and then we'll figure it out.
Yeah, and that'll depend on what technologies we're piggybacking on. If we're piggybacking on a technology that has a good interdomain solution, we'll have a good interdomain solution. If we piggyback on a technology that doesn't, we're not going to solve it for them.
Okay.
That's their business.
Yeah.
Okay.
Any other questions, or we'll move on to...
Actually, I'll give you the turn, and then I'll ask another question.
Okay, this is Subir. I heard that Norm said that wireline is the best bet because of that some of the packet loss requirement. So I'm just asking that within the scope, will there be any assumption that everything needs to work on wireline and no wireless, or it will be just independent of wireline and wireless?
I don't think either Lou or I agreed with that statement, and I believe it's important to address both wireline and wireless, and to the extent we can be agnostic about it, to be agnostic about it. But yes, you probably get a little bit better guarantee on wireline, but I think there's also a great demand for handling some of the traffic wireless, and we've got to address both.
So I think
I think another way of answering it, I don't disagree in specifics, but another way to look at it is we're talking about what happens at routers, and routers don't specify subnet interfaces. What they do is they specify requirements from the subnet technology. If that subnet technology provides what's needed to make work across routers, we work across it. So,
right. So
we're defining what happens at the router level. We're not defining what's happening at the wireline or wireless level. And certainly we're going to require a service interface.
Right. So I think that's I just wanted to verify that, right? But there may be cases that you need to have some knowledge of the mapping, right? Because otherwise it cannot deliver that. Whether that will be in the scope or not, obviously we have to figure it out. But I feel that there may be some, mapping would be required depending upon what the lower link can support.
I do think it's important for us to be chartered with at least one and maybe only one subnet technology that we consider.
Okay.
And that if there's other subnet technology specifics that happen either down the road as part of an order deliverable or even as a separate effort. But that's really an IESG call.
Okay.
But in terms of meeting reasonable timelines, number one, the architecture has to be independent of a subnet technology, but also we can't say that we're going to solve all the problems as part of the initial scope.
Okay.
And even potentially the eventual scope.
Yeah, and my last comment is that I sort of get it, but just want a clarification that your previous slides talk about both data plane and control and management separately. Now, there is no specific deliverable of control plane specification, but I see that it is within the data flow information model. So my question is that, is it that will be covered everything on the data flow information model, all control related plane thing, or
yeah. So the deliverables related to control plane show up in the architecture, and they show up in working with other working groups.
I see. Okay.
That's how we're proposing to form the working group.
I see. Okay. Thanks.
I think your answer there might have just answered the other question I've got, but applied to other SDOs in addition to other working groups. Do you see any, without going way into solutions phase, any dependencies or not obstacles, but considerations, especially in interacting with IEEE with the work that you're doing? I saw early on talk about what all is going on inside of IEEE, but then I didn't see any references to it later on in the description. I don't know whether that's part of the plan, or if it's not an issue, that's fine. I'm just curious.
Right. So a number of the IEEE projects are pretty far along. So other than some of the last two mentioned, the cyclic queuing and forwarding and the management of that, which I think are going to, or the policy management for that, which I think are probably going to get combined into one project. There really isn't any dependency likely, because they'll probably finish before, the other ones are probably going to finish before we're that far underway, and that last one we'll just have to work with as it goes. I think if we come up with something where we want a change or a capability that's not there or something, then we'll have to work with IEEE to get that going. And Norm has something he wants to say as well.
Yeah, in that respect, I think a number of us here in IEEE have as our eventual goal, when I write an application on that Apple that uses the network, I typically don't care whether the thing that I'm talking to is directly attached with a Cat5 cable port to port, or whether we're attached via a bridge, or whether it's going via Wi-Fi, or whether it's going via an RJ45, or whether there's a router between us, or whether there is it's being reflected off a satellite, etc. I've got my IP application. I get to talk to the other IP application, and that's it. To the extent we have to have, ideally, we just add a DSCP, make it work, okay? I want the application in my PC to not care what it's talking to and how it got there. I'd like the ability to request this service without knowing what's going on. So I'd like to see some coordination between IEEE and IETF so I can request the service in the same way whether I'm requesting the service from a router or a bridge.
Okay.
That's the level of cooperation.
So we're trying to move it along to do the poll questions so that we make sure to get to all of them.
Okay.
So
they're right back. Okay. So just as a basic reminder, we're not here just to talk about interesting things. We're actually here to figure out whether or not there's interest in forming a working group on this topic. And in particular, we really need to collect input for the AD and the IESG. And while we were doing some of those on the technical side in the Q&A, now we have to do some of the process things. So the first is, I'd like to get a feel of the folks in the room of How many folks think this described problem is a problem that we should be working on, that needs to be solved? Well, we'll ask in a minute about the IETF, whether the IETF should be doing it, but independent of who does it, do you care about this problem of TSN-type networks over routers? Show of hands, I can't hear, so I don't hum. Pretty good.
Like 50-ish?
50% of it. So it's certainly a good number. About half of the room, I'd say, just by my estimation. Should we, now that was an abstract question, should we as the IETF work on this problem? So I think it's probably a little less, but a pretty close number.
Yeah.
So going to, I think Ralph's question is, do you think this set of deliverables is a reasonable set to do as an initial set? Hands, please. So I'd say that's probably, that's
Maybe
less,
a quarter of the room.
yeah, less, but less people.
Yeah. For some reason, it's the left-hand side thinks it is, and the right-hand side isn't as sure. I'm not sure why. Oh, well, my left and their right.
All right, so as always, people don't like the way I ask questions. So we have two people who want to come to the mic. The first one is in the back.
For those who thought there's a problem there, thought that there was work we should do, so that don't think it can be completely reasonable time. Like somebody should say why that is. Because you think, you think it's a real problem, and you think that we should do it. And if you don't think it can be completed in a reasonable time, how is it a real problem? That's a real problem. It's all.
AC Linda, I think that 24 months, everybody was a real surprise that you'd be all done by then. I mean, maybe if there's candidate technologies and everybody agrees on the technologies, but there's definitely going to be more discussion of that.
Well,
that'll get it done.
It's your definition of reasonable time, not mine. It looks like. Yeah, you want to make that point? Deborah's point, just because she's not getting to a microphone fast enough, was keep in mind we're talking about the limited set of deliverables we had on the slide, not all possible deliverables and all possible impacts. It's just that for that specific set of deliverables, nothing more. Can we do it in a reasonable time with whatever your personal definition of reasonable time is? Here.
We don't expect OSPF to give us the solution in the timely manner.
Okay, so David?
Even so, I think this needs to be knocked down and nailed to the floor. We're going to do this. There were, I've heard L2, I've heard L3, I've heard L4, L3, I've heard about 4 or 5 data plans. We can raise my hand. This question is rigorous on the ocean without very well defined for this purpose.
I think the point of make sure we don't boil the ocean and have a tightly scoped charter that ensures that is a good point.
Okay, super.
So I didn't raise my hand that with a reasonable time frame because I didn't understand that when we are talking about the completing all the RFCs and everything, whatever in the scope we define, or we just understand that, okay, fine, this is the problem we are solving, here is a solution. Then 24 months.
I would say in 24 months, this is my personal definition of reasonable, is within 24 months to have the data plane defined and the architecture document defined, and both of those to the point where they're either to the IESG or very close to the point of being at the ISG. That's my definition.
Yeah, I think with this clarification, I would definitely raise my hand now because that was not clear, so that's why.
Well, we'll ask the question again once everyone has had a chance to speak at the mic.
Whatever you do, don't screw up my hardware.
Yeah. No, it's not.
I think doing this in a way that makes the hardware really expensive is probably not going to happen.
Oh yeah, Atlas. So two things. One on reasonable time. We're here to make interoperable standards. We're not here to write use case documents. We're not here to go through process. We're here to write interoperable standards. There's a lot of this technology which is well understood, including the hardware aspects at layer 2. So if at layer 2 if we have the hardware capabilities for specialized hardware that's going to care and be deployed in these type of environments, and we understand how to reuse a data plane encapsulation that's already well defined and exists, and we're talking about reusing the technology like RSVPT or so on, that product control protocols that already exist, and we're trying to put together an architecture to string it together based on existing proprietary implementations, and we can't do this in 2 years. I mean, if you all care about the problem, you can do it in 2 years.
Everything but the last part, I'm like, yeah, that's all a perfect statement for what I should have said. That last part, yeah, that's great that you said it. Well, maybe we'll just go to the next question, which was really about who cares about the problem enough to really work on it. Because an important part of having a working group is there sufficient people to go work on it? You know, one vendor who wants to work on it doesn't make a working group in the IETF. So, you know, who is really willing to contribute to this, either as an author or a viewer, or just someone who's really active in the working group? Can we see a show of hands? So I'd say that's about the same number who answered yes to the prior question. So basically everyone who thinks it's a reasonable, or approximately everyone who thinks it's a reasonable, we can achieve it in a reasonable timeline, is also willing to go work on it. Maybe that's why they raised their hands and maybe the others didn't. I think that concludes the polling part, and now we should give an opportunity for our AD to say something if she wishes, or any AD to say something if they wish.
Reiterating my co-AD. I think it's very important that all of you give feedback to us. We'll be making a decision on this, whether it should be a working group or not. So that's a very important decision. And so just see us privately if you want. And we're very interested to hear views, okay? And we have to determine that this is more than just one vendor and that there's lots of interest for this and it's doable. Okay, thank you.
We are pretty much out of time, so while I'd love to have a discussion on working group charter, I think for those of you who are interested in discussing working group charter, please subscribe to the DETNet list and then make your comments there. We'll continue that discussion in parallel with the process discussion that's being run by the ADs. Pat, do you want to say anything?
Yep. Thank you all for your attention today. Bye. I haven't seen anything yet. Unfortunately.
Emily dropped the published for return.